Hi, my name is Anika Valaru, and this is my lab report for Lab 5 in Physics 2211. So, the purpose of this lab is to find the coefficient of friction mu of an inclined surface by observing the motion of an object sliding down it using both experimental data and a model. The models and principles involved are Newton's second law, the velocity update formula, the position update formula, the friction force formula, and the force due to gravity formula. So assumptions and initial conditions include no movement in the z direction. There's a constant acceleration due to gravity of 9.8 meters per second squared. The origin is where the wall meets the table. And for the surface, the angle of the surface to the table is 29 degrees. The surface the x displacement of the object is 0.6 meters, and the y displacement of the object is 0.52 meters. Okay. So this is what the graph looks like of time versus x position. The two data sets don't end up aligning for tracker and model. Mu was found to be 0.063. So the main idea is this is 2D motion with friction, and we'll see later that there's a difference between constant and non-constant force of friction. The system is the object sliding down the incline, which is a whiteboard eraser, and the surroundings are the earth and the inclined surface, which was a whiteboard. So to the setup for the video, there's a meter stick in the video to be used as a basis in the tracker. The whiteboard, which was the inclined surface, there's a camera recording everything, and there was someone releasing the eraser. So this is what the video looked like. And so the setup for the tracker, I uploaded the video, and then the origin was where the table met the wall. The axes, so positive x is to the right and positive y is going up. The basis was based off of the meter stick in the video, and the time intervals were 1/30th of a second. And the point I tracked was the bottom right corner of the whiteboard eraser. So this is what the video looked like through the tracker. And this is the still image and the data and the graphs found through the tracker. And so for the coding process, I used the FNet formula, and I took into account friction, and I used the position update formula, velocity update formula, and delta t was the same as the tracker, 1/30th of a second. The initial position was taken from the first x and y points from the tracker data. So this is what the code looked like. You can see initial position, initial velocity, the mass was 0.5 kilograms. Delta t is 1/30th of a second. And then here you have FNet, the velocity update formula, and the position update formula. So this is the output from the coding. You can see x position versus time and x velocity versus time. And then I put the data into Excel. There are two sets of data, the tracker data set and the model data set, and I graphed them both together. So here are the two data sets, and here's the graph that you saw earlier. And so similarities, they both have the same starting point and direction of motion. The difference is, so the curve is a little different. The model's curve is a bit higher than the tracker. So possible sources of error. There was probably movement in the z-axis, but that was not taken into consideration. There were camera warps. Camera warps could have caused some issues. Also, constant versus non-constant force of friction. The model only took into account a constant force of friction, but it may not have been constant. What would the graphs look like if the object was traveling across a flat surface with a constant force instead? Both graphs would be the same because the force of friction wouldn't change over time. The force of friction would also be the same in both scenarios, so then the graphs would line up exactly. And then what if the object had just stayed at rest instead of sliding down the surface? What would that mean? If the object had just stayed at rest, that would mean that the coefficient of friction is so large that the force due to friction is greater than the force of gravity in that direction. So in this case, there would only be static friction because the object would be staying still. In conclusion, there is a difference between a constant force of friction and a non-constant force of friction. Thank you for watching my video.